Good morning students. In today's video we are going to cover this topic, seismology. So seismology is basically the science that studies Earth's internal structure using seismic waves. Okay, so logy is where this logy root word comes. That means it is something related to study of. Okay, so here it means study of Earth's internal structure using the seismic waves. So here comes the main part, using the seismic waves. Okay, so it is very hard for us to dig deep into the Earth's internal deep into the Earth, because the Earth's temperature, as we go deeper and deeper into the Earth's temperature rises very rapidly. So we can't able to see the all the layers that are present inside the Earth. So that's why we use these seismic waves used to detect earth tremors, earthquakes, nuclear blast, etc. So here are some use cases of this seismology. It helps us to detect the earth tremors, earthquakes, nuclear blast, etc. So these earth tremors and earthquakes, these help us to study the earth's internal. How? Let I will explain you a little later. 2000 years old concept, Chinese recorded the seismic activity. So this concept of uh, studying the earth's internal with the help of seismic waves is a very old concept, 2000-year-old concept, and it is first introduced by the Chinese people. Shang Heng invented the first earthquake detecting instrument 132 AD. Today we use seismographs to record the seismic data. So today we use these seismographs. As you can see in the picture, it has a pan inside this suspended ball, and this ball, it is very heavy, because if it is light it will cover it will means cover the very small disturbance. Okay, so that's why it's very heavy. And we have this stand and this graph on which we means this pan made the patterns. So what happens when the earthquake occurs? This ball shakes, and the pan on this ball, it creates the pattern on the graph. Okay, and this graph, on this the scientists study the waves, like where they are bending, where they are bending. So if the waves bend at that point, that means it changes layers, or it changes the medium. So the scientists study these waves, or we can say these patterns, that that this seismograph uh, covers or records, and it ultimately helps us to see the different layers present inside the Earth's internal structure. So let's study about the seismic waves. Seismic waves are of two main types: body waves and surface waves. So seismic waves are of two main types, that is body waves and the surface waves. And body waves are further divided into P waves and the S waves. Uh, yes. So body waves, as the name suggests, body waves that move inside the earth, and surface waves that move on the surface of the earth. So body waves further divided into these two waves, that is P waves and the S waves. P waves full form of these is primary waves, S waves, secondary waves. Primary waves, these travel very fast, like with the speed of 5 kilometer per second, 5 kilometer per second. So you can see, like every 1 second it covers 5 kilometer. So it is very fast. It is a longitudinal, that is push and pull motion like sound waves. So how it travels? It travels like the sound waves in the longitudinal motion, like this, like push and pull. Okay, the particles push and pull like this. Okay, each other like this. So suppose these are the lines. So these lines hit each other back and forth. So that's how the sound waves travels. And the P waves travels in the similar way. It travels through all the mediums, solid, liquid and gas. Compress and expand the material while moving. So when it moves, it compresses or expands the material in which it is moving. Now we have S waves. S waves is the secondary waves. So it is slower than the primary waves. 3 kilometer per second, that means 1 second. In 1 second it covers 3 kilometers. So you can clearly see the difference. So how it travels? Transverse, that is move at right angles to the direction. So it travels similar to the light waves. Okay, right angles like this. So this is the direction, we can say, and it moves like this in the right angles. Travel only through solids, not liquids or gases. So we can learn it like this, that S waves, S for solids. Okay, so it travels in the solid medium only and cause greater shaking than P waves. So when it travels, it causes shaking in the earth's surface more than the P waves. So let me summarize this page, that we have studied seismic waves are of two types: body waves and the surface waves. And in body waves are further divided into two types: P waves, S waves. P waves are fastest, it travels like sound waves, etc. S waves, they travel relatively slower than P waves, and they travel like the light waves, like in the transverse motion. Secondly, surface waves travel along Earth's surface, cause major damage during the earthquakes. So the major damage that is caused in the earthquakes is because of these surface waves. Two types: love waves and the Rayleigh waves. So these surface types are further divided into two types, that is love waves and the Rayleigh waves. Love waves move side to side horizontally, cause strong shaking, more destructive to structures. And the Rayleigh waves move in up and down like this, travel like an elevator motion in layered earth, often cause severe structural damage. So this is how the Rayleigh waves travel and move side to side horizontally. As means, I can't draw it exactly, uh, but I hope you can imagine like how the love waves travel. It travels like side to side horizontally like this, side to side horizontally. And the Rayleigh waves like this, rolling motion up and down. So these are means some this is the pictorial form of these waves. Okay, the first one is let me see. First one is P waves, this is S waves, this is love waves, this is Rayleigh waves. Just a second, I forgot to name these. Yes, so we mark them correct. This is P waves, this is S waves, love and Rayleigh. So as you can see, P waves travel very fast, so they don't have these curves, it's straight. S waves have little curves, then we have love waves, and then we have Rayleigh waves. So Rayleigh waves has these full curves. The most curves we can see is in the Rayleigh waves. In the love waves, you can see this last layer doesn't have the curve structure. So you can see these the pictorial form of all these waves, how they travel. So love wave travel like this, okay, the horizontally side to side, and these are up and down, so you can see it's in whole motion. Seismic wave behavior. So seismic waves reflect when they hit different layers, refract when speed changes between layers, diffract when they encounter obstacles like mountains or river valleys, etc. So this is how the seismic waves behave. Okay, because of these we are able to see the Earth's internal layers. Like if the seismic waves are traveling inside the Earth, and if it hit another layer, so it will reflect. So the scientists know that here the layer changes. So that's how the scientists studies these seismic waves. These waves show three behaviors, and because of that the scientists are able to comprehend that whether the layers are changing, or whether the medium is changing, or whether it met any obstacle like the river valleys, etc. Why seismic waves helps us? Sorry. So Earth is too hot to drill deeply. Maximum drilled depth is 12.6 km. So scientists use recorded seismic waves to understand the Earth's interior layer, composition, density, physical properties of rocks. So we can see that these waves, if they change any medium, so they will move slowly, or they will reflect. So that's how the scientists study the Earth's internal layers. So here what it says, that why the seismic waves help, I have already covered in the very first page of this presentation, that we can't drill deeply into the Earth. Okay, the maximum drill we can make is of only 12.6 km. So that's why we take help of seismic waves. So here's a structure, like you can see the Earth's internal layers: core, mantle, crust, mantle, core. And these seismic waves perform reflection, twin reflection, refraction, diffraction, sorry. Okay, so if I simply explain these all, that refraction is bending when it moves from one medium to another. Reflection, as you have studied in the junior classes, that means here's the structure. So this is how the light reflects. And diffraction is basically bending. Okay, like bending. As you can see, these waves are bending here, so here the diffraction is happening. So diffraction, basically like refraction happens when it changes the medium. Diffraction happens when it met any obstacle, like river, valley, mountains, etc. um, Earth's internal layers based on wave behavior. So so far the scientists, based on these waves, they have discovered these three layers that we studied today, that is crust, mantle, core. So changes in wave speed and direction help determine these boundaries. So I have already explained this. So today's homework is to make an image in your mind explaining this concept. So you have to make a flow chart or image, whatever you want, and you have to draw it in your mind. Okay, so you can draw it in on your page and then in your mind, that's totally fine, but it's very important to draw in your mind. Okay, because it helps you to improve your imagination. And as Albert Einstein said, that imagination is more important than knowledge. Okay, so with this, thanks for watching. I hope you have a nice day.